ASTM D2261 is a standard test method for tearing strength of fabrics using a single rip procedure as shown here. The material is initially torn at one edge and pulled apart using a measured force. This force is then used to calculate the tearing strength by the formula force over thickness. To recreate this experiment at home, I use a similar setup where two clips are attached to either ends of our material. The material for demonstration I used here is paper, which has relatively lower tearing stress than fabric. Now before conducting any experiment, we would have to measure the thickness of our material, or paper. Since each piece of paper is too thin, we can overlap multiple pieces of paper together, say around 10, and then measure the thickness for more accuracy. Now we can conduct the experiment. Now doing this experiment on only one piece of paper does not require much force. To increase the tearing strength, I could again put several pieces of paper together and then conduct the same experiment, but this time it will require much force that will be measurable. I tried using normal paper, but to model textile fabric, I used a stiffer and thicker paper made for calendars, and it was interesting to see how different materials can be torn and tested this way. Now to answer some questions, the specimen geometry would be a thin material and generally isotropic. If not, the material properties along its transfer direction or the direction of the tear should be the same. It needs to be shaped this way for the test so that it can be torn with a single rip. The measurements are thickness and force applied for tear, and tearing thickness is computed from these measurements. The biggest problems are applying the loads, as it is difficult to get a force that is exactly vertical where it is torn. Also, reading the load while it fluctuates as we rip the material can be very hard to get an exact measurement. Furthermore, other materials like fabric may require much greater force that would not be measurable with a single spring scale. Thank you for watching.